According to the Union of Concerned Scientists, there are 3,372 active satellites up in space as of the making of this video. But those are just the ones that we can still use. In addition to that, there are 3,000 dead or inactive satellites that currently orbit our Earth. But wait, there's more. There's over 34,000 chunks of space trash surrounding Earth as well. Why so much junk in space? Well, that's for another time. The thing is, now we have a bunch of things orbiting our Earth. Once in orbit, depending on how high their orbit is, they can orbit their orbit for decades. You know, just orbiting on their orbits. Wait, what is an orbit again, and why is this important? So an orbit is essentially a pathway that a satellite, which is any human-made spacecraft or a natural space object like a planet, takes around some other normally bigger object in space. It could be a moon, planet, or star. A close-to-home example of this is the International Space Station. The ISS is currently and always orbiting our Earth at a speed of 7.66 kilometers a second. That's like if something went from here to way over there in 1 second.
Yeah, that's really fast.
And the ISS needs to maintain this speed to be in a stable orbit. A stable orbit happens when the satellite in question has reached its optimal speed. At that speed, it won't veer off into the void of space, nor will it crash back down to Earth. It'll stay on path. This perfect speed is known as orbital velocity, and it isn't the same for every satellite. It varies based on the mass of and the distance from the object they're orbiting around. Take a look. If you are farther away from the Earth, you don't need to go as fast to maintain your orbit because the forces of gravity aren't acting as strong upon you. However, if you're closer, and thus closer to the center of the planet, then the pull of gravity acts stronger, so you'd need to go much faster to fight against it and reach your orbital velocity. Size of the satellite doesn't really matter. See, Jupiter is huge, but it still rotates around the Sun more than twice as fast as the smaller but farther Neptune. Earlier I mentioned that satellites can stay on their orbit paths for long times, and this is because they've reached orbital velocity. It's also easier to maintain a set speed in space where there are no air molecules for satellites to encounter. This goes back to Newton's law of inertia that says, an object in motion tends to stay in motion unless acted on by an outside force. With a perfect balance between velocity and gravity, there's nothing else that can interfere with an orbit. Right? Well, let's get back to space trash. Every time we launch any spacecraft, there's always a risk of being hit by orbital debris. Satellites that are already in their own orbits are also at risk because these orbits can overlap with some other satellite or space debris orbit and collide. Because of this, the ISS has actually performed emergency maneuvers 25 times between 1999 and 2018, and another 3 times in 2020. However, they were still hit by a tiny piece of debris that punched a hole into the Canadarm2 just recently in early June. Thankfully, it's still functional, but this is just a warning. Something worse could have happened. Good thing we have orbital mechanics to be able to predict where satellites are, where they're going to be, and how fast they're going. Okay, but seriously, we have to do something about the space trash.